Hi guys, Mrs. Jacqua. Unit 7 pretest dealing with triangular relationships. Good luck on your test. The test is in the classroom. Ask Mrs. Snyder and Mrs. Spillman for the test. Let's begin. Okay, what we want to do, question number 1, it says, what's name an altitude? Now, just a reminder, an altitude is a perpendicular height from one vertex of the triangle to another one. So if we were to look at that, I need to do this on my computer. If we were to look at this perpendicular line, we can see it's not going through the vertex. However, if we look at this perpendicular line, we can see that it's touching the vertex of the triangle. So an altitude is going to be ED. Now, what is a perpendicular bisector? The perpendicular bisector will be BG. The reason why it's BG is because left side equals right side from B. Okay, and what would be an angle bisector? An angle that's bisected where left equals each other. So that's going to be CF. And the median, now median is a super cool line that goes from the vertex to a bisector and bisects the opposite side. So that's going to be AB. Super cool. Okay, if AC is a median, what that just means is it goes from a vertex to the midpoint. So in other words, if AC is a median, that equals that. Those sides equal, so that's going to be C. Cool. If AC is an angle bisector, what that means is it bisected the angle. So angle BAC is going to equal CAD or DAC. So it's going to be that one. Number 6, if AC is an altitude, remember we're dealing with hypotheticals here. Crazy hypotheticals here. Because if AC was an altitude, that would mean that that's a right angle and that's a right angle. Which obviously it's not, but that's what it would mean. So ACD would be a right angle, 90 degrees. Okay, draw the appropriate lines to find the centroid. So what I'm going to do is I'm going to go to Math is Fun to remind us what a centroid is. Centroid is when you draw 3 medians. You get the centroid. So let's draw a median. There's a midpoint, from a vertex to the midpoint. There's my midpoint. Close, right? So use a ruler and a straight line to figure it out. Oh, wait, let's remind ourselves that's the same, that's the same. Let's go back to green, that's the same, that's the same. And then let's go back to our, we found the midpoint, used a ruler, found the midpoint of that. Then we just connect. And this is our centroid. Beautiful. Use a ruler and use your measures. Don't just make up stuff. Number 9, what's the circumcenter? So let's go look at our circumcenter. Circumcenter is when we have 3 perpendicular bisectors. Okay, so what we want to do is we want to find the midpoint, and then we're going to do a perpendicular line. To find the midpoint, use a ruler. We're going to do a perpendicular line. Find a midpoint, and find a perpendicular line. Okay, the circumcenter is not always inside it's not always inside the triangle. Happens to be inside the triangle this time. What that means is it's going to be equidistant from all 3 vertices. So if we were to draw a circle, oh, that circle didn't turn out very good. Anyway, if we could draw a circle on the outside, circumscribe it. Okay, draw the appropriate lines of the in-center. Okay, so let's go look at our notes because you took good notes. And in-center is going to be from the center. Now look what, oh, let's go back and talk about this circumcenter just real quick. See how that center actually moves to the outside and moves to the inside? But if I have a obtuse angle, it's going to be on the outside. If I have a right angle, it's going to be on it. And then acute angles will be inside. So back to the in-center. We're going to draw 3 angle bisectors. And then let's just kind of explore that a little bit, see how it moves. Okay, let's go back to my PowerPoint. Angle bisectors. Use a protractor. Or you can bisect your angles too. Whoops, did it disappear? It disappeared. Whoops, disappeared again. Whoops, disappeared again. Let me show out for you guys. My triangle's too low on my PowerPoint, so it's not wanting to keep up. So this would be my in-center. Cool. Use rulers, use protractors. And let's draw the orthocenter. So let's go look and see what an orthocenter is. It's all your altitudes stuck together. It can be on the outside, the center or the point can be on the outside, and it can also be on the inside. Cool. Okay, so let's go back and draw our orthocenter. We said altitudes. Really glad I know how to lock my iPad because last year I didn't know how to lock my iPad and it made for a nightmare when I was doing these kinds of things because I like to rotate my iPad. Okay, you get the gist of it. Good job. Okay, so if PO is an angle bisector of MON, find the value of X. Okay, what that means is these two angles equal each other. So you simply just say 2x. Oh, okay, let's start that one over again. 2x minus 10 equals x plus 15. And just solve for x plus 10. So 2x equals x plus 25. Subtract x. Then x equals 25. So x is 25. So the values are 40. Okay, find the point. Now this is a centroid definition. If I know what ED is, then BE is 2 times ED. It told us BD is 12. Oh, I picked white. That was crazy. Therefore, ED is 6. Okay, it's a 1/3 to 2/3. So this would be 2/3. What would be half of 2/3? 1/3 would be 6. They gave us extra information which we didn't need to know or care to know. Okay, so which side is the smallest? Well, the smallest points to my angle. And then my medium is going to be 2. It's going to go to H. And then the largest, which is 3 inches, is going to be to G. So the angle's smallest to largest, angle I, which is less than angle H, which is less than angle, oh, that's crazy. Let's do this. Angle I is less than, let's do measure. It's less than measure angle H, which is less than measure angle G. Just a lot of looking similar stuff. Let's do this. Let's put the little arc marks in the angles. There. Okay, so what is the longest side? List the sides in order of shortest to longest. So we're going to look for the short angle. Well, that's going to be PQ. The next angle is 55, and that's going to be PR. And then the last angle, which is going to be the largest, is going to be RQ or QR. So then we're going to put PQ is less than PR, which is less than QR. There's your order. Find the shortest segment. Okay, we got to find the shortest segment. It's always going to be. So we're going to look at our smallest angles, right? And that's dealing with that side. However, when we look at this triangle, that actually is our longest side. So then we're going to look for our shortest angle on the smaller triangle, and we're going to see that it's got to be X and Y is short. Go. Okay, if PO, I don't even have O in there. Totally have a typo in here. That should be PU. PU is the median of PTQ. PU is the median. What that means is this side equals that side. If UQ is 6, then what's TQ? It's going to be 12. Okay, if BD bisects ABC, find the value of X. In other words, this will equal that. So we have 3X minus 4 equals 2X plus 30. Let's add 4 to both sides. And simultaneously, let's subtract 2X. So then I'm left with X equals 34. And that's your answer. All right, let's look at number 19. Find out the possibilities for angle 1. Okay, angle 1 here is always going to be greater than, that's the wrong symbol. It's going to be greater than 2 other angles, this angle and that angle. Okay, so angle 1 is greater than those 2 angles. So what is that going to tell us? Might it be 118? No. Is it between 90 and 62? It might be, but we don't know that. there's a chance it's between the two. Is it greater than 0 and less than 62? No, because it's actually always going to be greater than 62, so it can't be this one. Can't be B. Is it less than 180 and greater than 62? Yes, it's got to be greater than 62. That's not that one. Find the values of this. Now, what we want to do is we want to take our pretty picture and we want to dissect it. We know that this angle matches that angle. We know that NW equals NX, so those ones are the same. And then we also know that we have a third side that matches. So what we know already is that these are going to be left side will equal right side. So my 15 is going to equal that whole thing. So x plus 3 plus 5 equals 15. This is 8. So let's subtract 8 from both sides. So then x equals 7. And that's what we get. Alrighty. Choose an assumption that would start to make an indirect proof. When we're given a proof and we want to prove it by indirect proof, what we want to do is we want to contradict what we're proving. Because we're not going to contradict what we're given. We're going to contradict what we're proving. So if we want to prove that 1 and 2 are not supplementary, then our indirect proof would try to prove that they are supplementary. So let's see. Okay, which of the following sets? Now remember, when I have A plus B angles or sides, it has to be, let's do this differently because we usually use smaller case. A plus B has to be greater than C. A plus C has to be greater than B. B plus C has to be greater than A. So let's find out which ones do and do not work. If I have 9 plus 4, is that greater than 12? Yes, so far good. What if I have 1 plus 2? Is that greater than 3? No. What about 5 plus 5? Is that greater than 10? No. What about square root 2 plus square root 5? Is that greater than square root 18? No, because you use your calculator. Square root 2 is 1.41. And square root 5 is about 2.34. And square root 18, you want to use your calculators on these just to make sure you're right. It's going to be 4.24. And so you could see that if I added square root 2, square root 3, that it's not going to be greater than this one, so it can't be that one. So my answer is A. Okay, write an inequality to compare EF. Where's my EF? EF to GH. GH. Now let's look at it. If I have 23, it's going to point to that side. And 20, which is here, it's going to point to that side. So it must be that 23 is greater than 20. We know that, right? And so HG is greater than EF. You can also write this as EF is less than HG. That's a cool way to write it too. Okay, 24. Write an inequality to compare measure of angle 1 and 2. So here's 1, and it's matching up to number 12. And 2 is matching up to number 11. So angle 1 must be greater than measure of angle 2. because 1's connected to 12, 2's connected to 11. And I am done. All right, guys, good luck. Have fun.